Hello everyone and welcome back to my channel. In today's video MtoA 524, I'll be showing you some day-to-day examples using Python and how that can make your life easier in terms of look dev and shading. So as you can see right now on the screen, you can see a Millennium Falcon which is made of Lego and it has tons of pieces, and to be honest, the look dev on this took me maybe I would say, depending how fast my computer running system is, maybe 20 seconds. So this was all done using a script. The only thing which has to be done up front is, I guess, shader assignments. So what part has what shader? So that's kind of the prerequisite which is needed. So I have been downloading this model from Mechabricks. They have tons of different geometries. And also, if you want to follow along and get the source code of this, it's on my Patreon channel. If you want to have access to my source files, you got to sign up for that tier and you have access to all previous source files and always the new ones. So let's jump right into Maya and let's get started by importing the model. So as you can see, it's clear Maya, nothing going on. I scaled the UI again so it's easier to read. And you can see the outliner is empty. So what I'll be doing now is I'll just drop in the model. So I go to my directory quickly. And this is what it looks like, the structure. So I have my Millennium Falcon DAE file, which is downloaded from the website. So if I just drag it in here, you can see that the asset will be imported. It's reading the file. It's, as I said, tons of little Lego pieces. But you'll see how it comes in. And like, I was a bit too lazy to do the manual process of actually assigning standard surface shaders and looking what color it is, setting scatter values on, I guess it's more or less like 20 shaders. So I just want to show you a quick way of accessing Python and how to get quick loops and setting up shading very fast. So once everything is loaded in, this is what you get. And you can already see I have the correct shader assignments, but it's different. It's Phong shaders. So stuff which is not really workable if you want to do some nice shading. You can see it's all Phong shaders, right? So, and you can see all my geometry comes in like just parts. So what I'll do first of all is select all the geometry and hit Ctrl G to just group it so my outliner list is not that long. So hitting Ctrl G, renaming this guy to GRP, or maybe just actually geo underscore, like that. So now I know everything in here is my geo group, and what I will be starting to do now is to find all the shaders. So I have my hypershade right here and it should load in all the shaders. You can see it's quite a few, but I'll clear the list, and in my outliner I have all these FBX files, and these are actually the same. These are the shaders. So if I just load it back in, you can see we should get the same list of shaders. If I hit 1, I can collapse the shader view, and if I hit sorting, it's just more collapsed view of all the things in here. So the idea is to convert all these inputs, first to convert all these shaders into standard surface shaders, preserve the file texture connections, and if the shader has a color, which most of them do have, let's say, you see this one is orange. So I want to create a new shader and make sure I preserve the color, right? So that is kind of the idea for this lesson. So the first thing what I like to do is just make sure I have access to Python. So in the script editor, I will do import pyml.core as PMC. It's just a shortcut so I can access it fast. So you can, some people do PM, some people just leave it, or PyML or whatever. So the first thing what I want to do, I want to store all Phong shaders in a variable. So shaders is equal to PMC.selected. Right now I don't have anything selected. So what I'll do now is I'll just drag all my shaders, make sure they are selected, select this line, hit Control and Enter. So everything is stored inside shaders, right? You can see everything is in here. So now is where the magic happens. So I can just do for shader in shaders, and let's say print shader, which is a function shader.color.get. And now you can see I'm getting all the colors, and sometimes I get 0. And in most cases, when I get 0, it has a connection. So my next check would be shader.color, I think, is connected. So if this is connected, I can say if shader is connected, maybe find the connection. So now I can go shader.color.list connections, and if I print this, I should get a list. Let's see what I get. So yeah, you can see I get a list of connections which are connected to color, and these are my file nodes. That is exactly what I want. So you can see it's only one item in that list, so I can just do 0. So it's just grabbing the first index it finds. So you can also do a loop on that, but that doesn't matter. So I can just say file node is this. So now I have a color, which is a file node. Sorry, I have a node, which is a file node, and I have a color. So if it's not connected, I do an else color, or let's say shader color, or let's actually say base color is equal to shader.color.get. So these are my two things. So either it has a connection or it does not, but then give me that the color of that shader. So this is my basic thing here. Right. So the next thing is, I guess, to just create a standard surface shader and make sure we can actually connect these things up. So I just want to store the variables. So I will just run this loop once. If I hit break, it will only go on the first shader and exit early. So if I run this, base color is not defined, but file node is defined, because in this guy we have the file node. What we can also do, let's just leave it at that for now. Okay, so let's create the standard surface shader. So for every shader in the font, I want to create a standard surface shader. So AI shader, and it also comes with an AI shader SE for shading engine is equal to PMC, and then you would do hypershade, if I find that correctly. Sorry, it's actually rendering, not hypershade. And then you would do shading node, which is of type AI standard surface, like so. And if I run this, I think if I just do as shader, we might not get the engine, but let's see. If I just run it like that, let's make this a bit larger. If I just select this and hit Control Enter, you can see we actually just get the standard surface, and that's actually all we want. So we don't care about the shading engine in this point of time. So if I run this now, and it will create the AI shader like that, and whatever is in that variable is our shader. So what I can do now, by having file color, a file node, I can actually connect the file node directly to the shader. So because it's a Lego piece, I don't want to work with diffuse. I just want a full scatter shader and control the scatter effect with the scatter scale, right? So just to make this a bit more clear, I will not go into the else loop, but I will always query the base color. So if it's connected, it will be black. And if it's not connected, it will get a color, right? So I just exited out of that if statement. Okay, so we've got the shader. So the next step is, let's just set the color, which we retrieve from the function shader, to the subsurface color, right? So how do we do that? We just do, because we have the shader, AI shader dot, I think it's called subsurface color. Let's just do get to see if it actually exists. And it does, it returns white. So we just want to set it to base color. So it's either black or it has a color, right? And this should happen before I do the file node connection. Or what I can do too, I can just say file node is equal to none. And I'm always setting the base color. And now I can check if file node is true, then do file node.out color connected to AI shader dot subsurface color. So what this is doing, it is checking, hey, did I actually find a file node for this? And if so, then hook it up. So let's see what this is. So we definitely have something in here. So file node is definitely true, and file node has an out color attribute. So let's just hook this up with the subsurface color and see what this does. And you can see it finds the file node and it connects it to subsurface color. So this is the first setup I want to do, which is actually pretty nifty already. So whenever it has a file node, connect it up. So the next step is the radius. So what I always tend to do with my subsurface radius is have it a bit more desaturated and a bit brighter. So to get that working, I want to create a color correct node. So our AI color correct is equal to PMC rendering dot shading node AI color correct. And then we have as shader is equal to true. So this is my color correction node, and I execute that, and I'm creating the AI color correct node. So I'm getting the base color, and what I want to do now is, because I know I will always have a base color, I will go AI color correct dot, I think it's called input dot set, which is the same base color. So if I run this, base color is not defined because currently we did not have it. But if I just run base color like so, we got black here. And if I just set this to my color correct node, the input color now here is set to black. But again, if I have a file node, I want to connect the file node's out color to my input of the AI color correct. Like so. So if I run this, we should get a connection. So you can see the same file node is connected to the color correction node. So in here, in the AI color correct node, what I like to do is change a few parameters. So I like to change saturation, and that's fairly easy to do. I can do it when I create it up top here. So what I want to do is AI color correct dot saturation dot set, and I, let's say, want to do 0.75. Execute this. You can see it's being set. AI color correct dot exposure dot set is 0.5. So I'm increasing the exposure. So I'm increasing the exposure by half a stop. And you can see that's what's happening. So I have this connection ready to go. So the only thing I need to do now is connect the out color of the color correct to my subsurface radius. So this should always happen. So I can do it right on top. AI color correct dot out color connects to AI shader dot subsurface radius. Let's see if that works. Yes, and it's hooked up. So this is now the next step, right? So I have my scatter settings. All I got to do now is set, I got to set the weight to be 1. And I want to disable base, right? So that's also things I got to do. So in my AI shader, I want to set weight. I think it's just base dot set is 0. Yeah, I think this needs to be a tuple just to specify the color. Oh no, sorry, weight can be white. 0 because it's a float. But if you want to set the color like this, base color, it's just a matter of habit. That's what I do. I always want the color to be also black. So these two values now should be set to, so the weight is 0 and the base color, why does this not work? Does not support base color. It needs to be set. Let's see if this works now. There we go. So now base color is set. And we want to have subsurface weight to 1. So AI shader subsurface. I hope it's like that. Oh, it's just subsurface.set is equal to 1. You can see now everything is turned on. So next step is to set the scale. And I want to set the scale to AI shader.subsurface scale.set to, let's do 0.025, 0.025. And now we just need to set the type, which is random walk. I can click it, I can see what type it is, and I get actually the output here. So let's just copy and paste this line here and change the attribute to subsurface type and set this to 1. So now we're setting random walk 2. So subsurface is set, base is set. What else do we got to do? We want to connect a round corner shader to the normals, right? Let's just, and we can also set the specular roughness to, right now it's on 0.1. IOR is like that. We can see if we can use a different one, 550 if we want to do that. Let's just do that to get a plastic response. So this would be, oh, actually, I don't know, specular IOR maybe? I don't think this will exist. I actually don't know. Oh, almost right. Specular IOR set 1.55 was the preset. Okay, so we got specular set up, base set up. Okay, the next thing is, as I said, is creating the bump. So we always want to have a bump, but we don't want to create it for each shader because it's a uniform object. Each Lego brick has the same round corners, right? So let's just do a round AI round corner is the same PMC rendering shading node, and then we do AI round corners as shader is equal to true. So we have a round corner shader. We want to set the radius right from the get-go. Corner dot radius dot set. Let's do 0.025, or it's 0.1. Let's just do 0.05. So that is set, right? And then we want to create a bump. So let's do AI bump is the same story. PMC rendering shading node AI bump to D as shader is true. So we got a bump. So next is just to connecting these guys up quickly. So we want to have AI round corner dot out value connecting to AI bump dot normal. Connection is made. I don't think the height plays a role because it's driven by this guy. And then for each shader we create, we want to connect the bump out value to normal camera. So for each shader we create, here's the shader creation. So let's just do it right down here. So we want to do AI bump dot out color connects to AI shader dot normal camera. So this is the connection for the bump, right? Out color was wrong. It should be out value. So now this connection is made too. So we have a bump, we have specular, we have scatter, we have disabled base. So what else is there to do? I think we need to connect the standard surface shader. We need to connect that with the shading engine of the Fong shader, this guy. And how do we get that? So let's do a how's it called? shader.outColor.list connections. Let's see what this gives us. And this actually returns us the shading engine. So that's exactly what we want. So we can just take the first index of that list and store this into shader SE, like so. Okay, so whatever's in shader SE is the shading engine of the Fong shader. You can see that's working. So the only thing we got to do now is hook up the out color from the AI shader to my shader SE. So AI shader dot out color connects to shader SE, and I don't know exactly how it's called. Surface material, surface shader. Is that still connected? Okay, so it's definitely called surface shader. So let's just do dot surface shader. So this connection is now being made too. And one thing, I think this is really the last thing, is if it has a file node, change the color space. So I know this is not ACES, and I'm pretty sure this is sRGB texture. So if it has a file node, so we are on this little loop here, what I can do, I can go to file node color space dot get just to see what it's right now, and you can see it's a string. So I want it to be a utility. Depending what you have in here, this is what you got to set, I guess. So I want a utility sRGB texture. So I'm telling the renderer, hey, this is an sRGB texture. If I get the value now, you can see it did not update because I was definitely changing the wrong file node. I need to change this guy. So let me just do file node.select. I think this should select me the node. And let me change it on this guy. And then I can read it. So utility sRGB texture, and just read this value, which is this string. So if I copy this, Control C, and instead of get, I do a set, and I want to set a string, this should hopefully set the color input space for this. So if I save my PY file right now, and I delete all these nodes, which I have created beforehand, let's just run this and see. So I still have the break in here, so it will only run for one shader. Control Enter, and let's see. Okay, so we did not get any errors, as it seems. And we have a shader, we have a connection to the color correction node, which is our cat thingy. We have a connected bump, we have round corners, we have base turn off, we have speculum 1550, we have scatter on, random walk on. So all these things are exactly as I want them to be. The only thing which could be nicer is we could have a name for the shader. And let's see if we have the connection to the shading engine. We do have it right here. Okay, let's see if I hit undo, if we can get rid of the creation. Okay, so everything is back to normal, how it was. So I just wanna, once I did the connection, I just wanted to delete the Fong shaders because I don't really care, I don't want them. But before we do so, I just wanna copy the name of the Fong to the standard surface shader. So in here, actually, you can specify, if you click on the blue, highlight the blue and do quick help, you get a list of things. So I can actually specify a name. So is there a way to collapse that? Yeah. So the shading, the standard surface shader should get a name. This is prefixed by AI underscore, and I'll just do a curly bracket and do a dot format, which is a string replacement technique for Python. And I'll just do shader dot get name and see what this, if I just run this, you can see this is the shader name, and I'm just prefixing this with AI underscore. So, and whenever all my things are done, I want to delete the Phong shader. So I can just do shader dot, oh sorry, it's PMC for PyML core dot delete. Control spacebar actually does your auto complete. And I want to delete the shader, which is the Phong, right? Which is this shader here. So if I save my scripts and save my scene, what I'm expecting to see now is all these shaders being replaced with standard surface shaders. So let's see. I have a clear scene graph like that. And if I just run my AI corner and I delete the break at the bottom, so now I'm looping over every shader, hitting Control Enter. So let's see. You can see something happened. We got a long list. We have lots of connections. So if I just hit 1 and I do sort, let's just hide the script editor and see the hypershade. What do we get? So we get successful connections to the color corrects. Everything is correct, connected. I have my exposure, I have my saturation set. They go into my new AI prefix standard surface shaders. And then at the bottom, let's see if I have the raw colors in here. It should be scatter. So this is a white color. This is red or whatever it is. And it seems all to be just working out of the box, right? So let's see what the viewport looks like. So everything is definitely converted. You can see we get also the surface colors back. So we get red here. So it seems everything went just fine. So let's just try to preview the textures too and see if they load in fine. You can see we got a texture right there. Let's check our characters lined up here. So everything is definitely looking good to go. And you can see now how versatile this is. So let's just add some lights and see actually how it does look rendered. So let's just load in a quick studio setup and we see what we get. So you can definitely see the render has been kicked off, and you can see everything is working. I'm rendering right now into the viewport. So if I select my light source, we can play around with intensity settings and stuff like that. Let's see, I got my skydome light right here. Let's just go up on the exposure, maybe 2. And you can clearly see this is very similar to result as I was getting in the nuke thing here, right? So obviously I added more lights and added some nice backlighting and all that. But in general, you can see how very complex and easy it is though to set up these kind of setups using a script. So if I just create a new light and let's just put it somewhere. I'm not sure exactly where it comes to on default. It's right here. And let's just put it in the back and see what we get. Alright, so I've got my light source right behind the ship, and if I bring up my exposure maybe to 15, you can see now something is appearing on the back there. So let's go maybe on 18. And you can see now we get some nice shapes here on the back. So if I just move this up, let's see. You can see how it starts to creep over the ship. And this is kind of a simple backlit ship now. So I just want to show you one more example how this is actually speeding up your workflow immensely by just loading in another asset. So if I stop the render now, and I'll just save it, and I'll just bring in a new object. Let's do what can we do here? I have an X-wing, or let's just see how the X-wing behaves. So if I just drag that same object, like the DAE thing, in here, let's see what we get. So it will load in all the geometry, and after that we will just run the script and we should be good to render actually. So the same deal, we get all the parts. So I'm just scrolling down and then I'm just grouping them. So we just have them all in one place. Let's see, go all the way to the end. Select Ctrl G. I'll just leave it as it is right now. And you can see now we got the FBX shaders back. So if I select all of these guys and I go back to the hypershade, like so, let's just hide the attribute editor, open up the script editor, clear this, and load in the new FBXs by just framing them. You can see now we get the same kind of setup. We have textures again, we've got base colors. So let's just store this selection into my shaders group, like so. So everything is now stored in this guy. And also these things currently I do. I still have them in memory. So what I can do with, instead of recreating these guys, I can just reuse them because they are still from my previous execution, right? So I don't need to run this selection. I can only run the bottom piece. So if I select this, I just like to hit save just in case. And after it's being saved, I will just run this, and hopefully all the new FBXs, let's just maybe prefix this just to get shader conflict names out of the way. So let's call this X-wing, like that. And let's just run this again. So up from the bottom, delete to my first for loop, Control Enter. You can see something happened. We got now AI X-wing shaders. And if I just hide the hypershade, go into view panes, and let's see if we find the group like that. And if I move it up, if everything went well, these should all be now connected, correct color space. So let's just open up the render view, hit the play button, and see if it worked. It's exporting the scene, so all the geometry is being exported, and there you go. You can see now everything is just rendering just fine in the Arnold universe, and you can see how fast and versatile this is. If you have set up the script once, all you gotta do is apply it and just render it, right? And let's say I want to change the round corners on all the shaders. What I can do, I can go into the shader of that specific piece, can go into geometry. I know here's the bump map connected, go in here, go into my round corner shader, and if I think it is too round or not round enough, I can just change the value, and you can see overall the round shader effect is reduced or stronger, right? So that is the beauty of all this versatility and flexibility. And I hope this just showed you the immense power of Python. And honestly, this should be for most people very straightforward once you understand the concept. So I'm creating a node here, I'm storing that in a variable, I'm getting all my shaders like this, the current selection, and I'm looping over each object in that long list of shaders in that selection. And then I'm creating a shader in that loop. For each shader, I'm creating a standard surface shader, a color correct node, and then I'm just setting values, connecting values, checking if it has a connection. If it has a connection, use the node of the connection and all that. So that is the kind of the basic idea of that scripting, like on a day-to-day basis, I would say. And as I said in the beginning of this episode, all this stuff is accessible through my Patreon channel. Obviously, you can just rewrite this, follow the tutorial and write it up yourself, which is recommended anyways. So be sure to check that out. And if you want to work with those models, which I'm using right here, just go to Mechabricks, download them, play with them, see how you can improve your renders and all that. So thank you guys for tuning in. And I hope this was a nice, refreshing tutorial on coding, scripting. So thank you guys, and I will see you in the next one.